Hello everyone. In this video we are going to learn about how to write electron configurations for ions. Right? So let's start. So first of all, let's see what an ion is. What is an ion? Right? So we have a neutral atom. For example, say sodium is a neutral atom, and then the ion formed by sodium would be Na1+. Right? Say fluorine is a neutral atom, the ion formed by fluorine is 1-. Right? So what are ions? Ions are atoms that have a positive or a negative charge. Okay? So if an atom has a charge, that means it has different number of electrons. Right? The number of electrons is different. Remember, we still have the same atom. So if we write sodium atom, right? So this is the neutral atom. That is still sodium. And then when we write down the ion formed by sodium, it has still the same symbol Na, right? So protons is same. The protons do not change when we make an ion, right? Fluorine is still fluorine. So fluorine has still 9 protons and fluoride ion has 9 protons, right? The only thing that is different is the number of electrons, right? It's the number of electrons that gives a positive or a negative charge to a neutral atom. Now, based on their charges, we have two types of ions, cations and anions. Cations are the ones that have a positive charge. So these are the positive ions. And anions have negative charge. So how do I remember that cation has a positive charge? Look at the word cation. It has a T in it that kind of looks like a positive sign, right? So we can tell that cations are positively charged ions and anions are negative, right? So when a neutral atom loses electrons, that is when cations are formed. So cations have less electrons than the neutral atom. Whereas anions are formed when a neutral atom gains electrons. So anions have more electrons than the neutral atoms. Right? Example, sodium neutral atom has 11 electrons because its atomic number is 11. But sodium ion, which is a cation with a positive charge, has 1 less electron. So that is why there is a charge of 1+. Right? So it has 10 electrons. Anion have more electrons than their neutral atoms. Example, nitrogen has 7 electrons because it has 7 protons as well. Right? So that's why the atom is neutral. But nitride ion will have 3 more electrons. So 3 extra negative charges that sit on the neutral atom, and now this is an ion, right? So nitride ion, it's the ion that is formed by nitrogen, has 3 more electrons than the neutral atom. So hence the number of electrons is 10. Okay. Another example, let's try to write down the electrons in a neutral atom and the ion formed by that neutral atom. Calcium atomic number 20, so it has 20 electrons. Calcium 2+ will have how many electrons? Now look at the charge on the calcium. It is 2+, meaning it has 2 less electrons, right? So the number of electrons will be 18 in calcium ion, right? Now let's look at sulfur. Sulfur has 16 electrons because the atomic number of sulfur is 16. Now look, sulfur has a charge of 2-, right? It means it should have more electrons than the neutral atom. How many more? The charge is 2 negative. So it has 2 more electrons than the 16 electrons of the sulfur neutral atom. So sulfur 2 negative will have 18 electrons. Right? Now let's come to the ion configurations. How do we write the configuration of an ion? So first of all, let's first see why would an atom make an ion. What is so special about making ions, right? So atoms want to look like noble gases. What is so special about noble gases? They have full shells, right? Full S and P sublevels, right? Now, in order to gain a full set of S and P orbitals, the atoms either gain electrons or lose electrons, right? See, noble gases have a full set of S and P orbitals. This is the example of neon. You can see neon ends in 2s2, 2p6. So n equals 2 is full. The outermost shell or the valence shell contains the max number of electrons, which is a total of 8 electrons, right? So noble gases have 8 electrons in their valence shell. And all the atoms want 8 electrons in their valence shell, right? So how do we write the ion configurations? So first step is find the closest noble gas, right? Example, calcium has 20 electrons, right? And calcium is in the 4th period. Right? So you can see calcium is in the 4th period. That's calcium. So there are 2 nearest noble gases, one in the same period, that would be krypton, and one in the previous period, that is argon. Argon has atomic number 18, krypton has 36, right? So which is closer to calcium? Now calcium has 20 electrons. So argon with 18 electron is the closest noble gas, that has 18 electrons, right? So the nearest noble gas to calcium is argon with 18 electrons, right? Now calcium would want to lose 2 electrons just to look like argon, right? So when it loses 2 electrons, it becomes calcium 2 plus, and that kind of looks like argon, right? So calcium 2 plus will have the same configuration as that of argon, which is a noble gas. Okay. Let's see sulfur. Sulfur has 16 electrons, right? And the nearest noble gas to sulfur, which is in 3rd period with 16 electrons, is either argon or neon. So in order to look like neon, it will have to lose 6 electrons. And in order to look like argon, it has to gain only 2 electrons. So gaining 2 is easier than losing 6. So sulfur would like to look like argon, right? This is the closest noble gas. Now if you take out electrons, you end up in a cation. But since sulfur wants to gain 2 electrons, so it gains 2 electrons to look like argon, because the nearest noble gas is argon. So when it gains 2 electron, sulfur 2 negative has now 18 electron, which kind of looks like argon now, right? So this is how and why atoms lose or gain electrons because they just want to look like their nearest noble gas, which have a full S or a P subshell. Right? So now let's look at some examples on how to write down the configuration of ions. So first we are going to talk about the cations. Right? So when we write down the configuration of a neutral atom, there are so many neutral atoms like copper, right? So there are so many electrons in a copper neutral atom, right? I don't know which electrons should I remove when I'm making a cation of copper, right? So the rule is we always remove the electrons from the highest energy level. What is the highest energy level? Or the valence shell, that the energy level that has the highest value of n, right, which is usually given by the period in which the element is located. Now look at copper. Copper has this configuration, right? Now the highest value of n is n equals 4. This is n equals 4. This is n equals 3, right? So when there are S and P electrons with the highest value of n, these are the electrons that you would remove first, right? So if I want to make copper 1 plus, I can take out one electron from the 4s orbital, not the 3d orbital, because n equals 4 is greater than n equals 3, right? So this is the highest energy level, highest value of n, right? So copper 1 plus would be 1s2, 2s2, 2p6, 3s2. Now I'm going to write 3d10 like that. I removed one electron from the 4s orbital, so the configuration now is 4s1, right? So this is copper 1 plus. Now let's say I want to make copper 2 plus. Again, the highest value of the n in the neutral copper is 4s2, right? Since I'm taking 2 electrons out of the neutral atom, I will take these 2 electrons from the neutral copper, and now the configuration would be 1s2, 2s2, 2p6, 3s2. Now this whole 4s is gone. So this thing is gone now, right? And because I took out 2 electrons, so these 2 will go, and now it will end in 3d10. Okay? So this is how we write down the configuration of ions. Okay? Now let's do some practice problems from your worksheet number 5. So let's do some problems from worksheet 5, configuration of ions. So I'm going to go to the 3rd page of this worksheet, where we have write down the noble gas configuration of the following ions, right? So I'm going to do question number 9 on that worksheet, right? So let's start. Now how do we write noble gas configuration of ions? So first of all, we need to write down the noble gas configuration of that neutral atom, right? If you check your periodic tables, let's do selenium. Selenium is located in 4th period, right here, that is selenium. So we will use the noble gas in the previous period, which is argon, and then write down the extra electrons. So argon plus 4s2, 3d10, 4p1, 2, 3, 4, 4p4, right? So I kind of already wrote the configuration in terms of noble gas for selenium with 34 electrons. Now which electrons should I take out? Since I am making selenium 2 negative, it means I'm adding 2 electrons, right? I'm not taking off any electrons. So I'm adding electrons. Electrons are added to the highest value of n as well. Look, P has 4 electrons. 4p has 4 electrons in a neutral selenium atom, and the max and p orbital can have is 6 electrons, right? Since I'm adding 2 electrons to the neutral atom, those 2 electrons will go to the highest n. So this is highest value of n, which is equal to 4. So I will add 2 extra electrons to this very orbital, right? Now the configuration becomes, so I'm gonna still write down the noble gas configuration. It's argon, then we have 4s2, 3d10, and now since we added 2 electrons to the p, 4p, the configuration becomes 4p6. So when you are making an anion, you add electrons to the highest value of n. When you are making a cation, which is formed by losing electrons, you take away the electrons in the highest s or n, right? So let's do another example. So this is the noble gas configuration of iron with 26 electrons, right? Now the highest value of n is 4. So we have this right here. And we are now removing 3 electrons. So first we will remove 2 electrons. These 2 will go. So we remove these 2 electrons. These 2 will go. And now we have to remove 1 more electron. See, iron has a charge of 3 plus. So we need to take out 3 electrons. So take away 3 electrons, right? 2 will go from the highest n, which is 4s. Now the next is 3d. So we will take 1 more electron from 3d, right? Now the configuration of iron 3 plus becomes argon, still the same noble gas. The 2 4s are gone now, and then we took 1 more electron from the 3d, so that would be 3d5. So this is the electron configuration of iron 3 plus, right? Now let's do one more example. Let's do chromium 3 plus. So this is the chromium neutral atom. This is the configuration of neutral atom. Again, we are taking away how many electrons? 3 electrons, because it has a charge of 3 plus. Take away 3 electrons, right? So how will we take away 3 electrons? Again, the highest value of n is 4. So take away these 2 electrons. So 2 electrons gone. And then I still need to take away 1 more. That will now go from the 3d, right? So take away 1 electron from the 3d orbital now. So what will be the configuration? We still have argon. The noble gas would not change when you're writing the noble gas configuration of ions. Same noble gas as that of the neutral atom. So this is argon. Now we took away the 4s, 2 electrons, this orbital is gone now, and 1 from the 3d. So we are left with 3d3. So 1 electron gone from the 3d orbital after we took away the 2 from the 4s orbitals, right? So this would be the noble gas configuration of chromium 3 plus. Okay. That's all, guys. Hope that video is helpful. Thank you.